Okay, so I was asked to talk about factors that promote as well as factors that limit soybean. I think originally it still says inoculation, but I think we meant nodulation.
Yeah, better.
Because factors that promote and limit inoculation is farm workers and farmers, practically doing it. What is these factors that promote and limit nodulation? I must just get there we go. Down is up. Once again, I need to tell you what I'm going to do with you. So first of all, we're going to recap nodule formation, but I think we can sort of skip that one because all the other speakers today spoke about it. You must tell me if, because I can't stand still. I'm like a good micro. I walk around in the rhizosphere. So if you can hear me or can't hear me, just tell me, but I think I can project my voice. Yeah, but then I go like, start playing drums or something. So the recap is going to be very quickly. Then we're going to look at the factors that promote nodulation, then the factors that limit, and then you've got the floor to ask questions. So the process and the results. You've heard it from all the other speakers today, but the one that I want to focus on is flavonoids. How does the process start? Where does the process start for nodulation? The plant. The plant experiences nitrogen limiting conditions. And then the plant sends out the flavonoids to get hold of the rhizobia if they are there in the environment. I can't hold that. I'm going to play like a drum. Hello? Can't you hear me? Who can't hear me?
The recording.
Oh, the recording. Oh, is this on? Hello? Is this just for the recording?
Yes.
Okay.
I will be recording everything.
Oh, you should have told me. I could have, made like interesting things on stage. Always, I can always do that as well.
It's a family show.
Oh, sorry, Tom, I forgot. Okay, so the important thing I'm trying to say is that the plant initiates. You can put as many rhizobia in the soil as you wish. If the plant doesn't initiate, nothing will happen. So I'm not going to go through the rest. I will not like it to press. It doesn't work. Crackle. It's a possibility. Maybe throw it. It's not working. I will then not be recorded, so I can now go loose and say whatever I want. There's no evidence of the nonsense I'm going to talk. I know that's his cell phone. I thought he was coming with the microphone. Okay, while we're sorting out those issues. He was muted. Now you must tell me how not to mute. Okay, now I mustn't shout. Now I must talk like in a deep voice to make it interesting. Okay, let's get back to it. The plant decides, the plant initiates. And then from the process, we get the results, nodulation. Now I'm not allowed to walk around, I'll have to stand right here because this thing is going to scream at you. Like Jonathan told you in his talk, matchbox size, crown root, top. Where do you want your nodules? And there they are. And then at the bottom you can see they cut open. And we don't believe in pink, we believe in medium rare steak, maroon. That is what it looks like when it's active and when it's binding. But you'll see I don't have any reference to the company that I work for, so I'm not punting
any company's products, but I'm punting Rhizobia in general and soybeans. Okay, so relax. I'm not going to do a comparison with the other companies. So that is the process and that is the result. The one thing that some of the other speakers didn't say is if we look at how do we get into ammonia, is there's 4 different fixation routes or ways that we can actually show it. The first one on the left is the empirical reaction. So it's one N2 molecule, 2 ammonia molecules, and you need 6 electrons and 6 hydrogens to get that done. So that is the basic one. Then on the right-hand side is the molecular reaction, where they say 1 atmosphere and 25 degrees Celsius. Same thing. On top is the biological one, biological nitrogen fixation, nitrogenase enzyme. You can see 16 ATP, and we all know ATP is energy. Okay? 16 ATP is quite a lot of energy. The one at the bottom is the Haber-Bosch process. That's how we do it industrially. And if this doesn't fill you with awe, nothing in your life will fill you with awe. Look at the Haber-Bosch process. What are the requirements? 300 degrees Celsius. That's boerhard. Excuse my Afrikaans. 150 atmospheres pressure. Dis baie woordryk, ja. Thank you for corrigiering me there. So, what we as humans do at that temperature and pressure, nature does at ambient temperature and 1 atmosphere pressure. If you don't have goosebumps, come see me afterwards. I've got horror movies that I can show you. But this is amazing. Then, if we look at the biological one, symbiotic biological nitrogen fixation, 16 ATP. They say for that process per mole, it's about 184 calories. Now, we all know how to burn calories. Some of us do it. I can see in the audience, some of us wish we can do it. And some of us really need to do it, but we don't want to. So, for that reaction per mole, we have to climb stairs for 20 minutes. I don't know about you, that's a bit tiring. Or we have to walk for 44 minutes. Or we have to jump rope for 14 minutes. That's very energy sapping. So this process in nature needs a lot of energy. You can see there in that little red square, for each kg of nitrogen fixed, you need 10 kgs of sugar or carbohydrates. It's a very energy demanding process. And that is the reason why I say the plant needs to be healthy. If the plant is under stress, this is not going to happen. If the plant is under stress, it is not going to go this way, because it takes a lot of energy. If the plant has got nitrogen available to it, it is not going to do this. I usually make the joke and I say, you know, it's like children. There's sweeties and there's vegetables. Children will go for the sweeties. And then there's some kind of wise person in the audience that tells me, no, theirs goes for vegetables. No, man, nonsense, you're lying. The sweeties is the nitrogen fertilizer that we give. The plant will use that before it will go to the veggies. And depending on how much we put in, by the time that the sweeties are done, the vegetables are verlep and vrot and can't work anymore. You are very lucky if you get late nodulation because you've got too much nitrogen. Because there's so many things that need to work together and need to be perfect for this to work. So once again, let's not fall into the trap of Americans. More is better. More ain't always better. It depends. If it's liquor, yes, probably. But more ain't always better. We always want to know how many nodules, how big, where, what, where, how. 7 to 5 nodules 2 weeks after emergence. That is sufficient if the conditions will stay favorable, because the plant will keep on nodulating up until R5. Then the nodules will start dying off. How can I explain it in a different way? More nodules is not the goal. A healthy plant is the goal. There is a thing like overstimulating something. I'm sure I don't have to give you examples. You can hear I can go really underground. But there is a thing like overstimulation. More ain't always better. But yes, we do not plant in conditions that are favorable anymore. And that's why more maybe is better, because you're going to lose quite a lot of them. But the more important thing is a healthy plant to supply the sugars and the carbohydrates for the process to take place. Okay, so let's go to factors that promote. It's quite boring, actually. Probably not for you, because hopefully you know everything, but for me it's boring. But every day you need to learn something else. I'm sure there's going to be wonderful questions that's going to challenge me. But yes, first thing according to me, and remember, it's like in science or like research. When a university does research and they bring out the results, what's the first thing you do when you don't agree with the results? You look at who sponsored the research. So if you're in a biological company, and it's a chemical company that funded it, and they tell you that, no, bacteria does nothing, doesn't work, then you wonder about it. Remember, I'm a microbiologist. I used to grow these little thingies. I almost said since inception, my inception, but that's a lie. But for many, many years, don't let my good looks fool you. I've been in this industry for quite some time. So, according to me, first thing that promotes nodulation is nitrogen deficiency, so that the plant can send out the flavonoids to attract the rhizobia. And this is not a strange thing. We think it is. It's not. It's like Prof. Karen told you this morning, it's like having a household with 15 5-year-olds running around screaming, being hysterical. That's what it is in the rhizosphere. Everybody is there. Everybody wants to do something. It's hectic. And if they don't get the right signal or the right key to the door, they cannot enter. It's not just with rhizobia that it works this way. It's with all your other living fungi and bacteria and mycorrhiza that it works this way. The plant detects a problem and sends signals out to ask for help. Second thing important for nodulation is a healthy seedling or a healthy plant. And I know probably you're going to fight with me at the end and say, yeah, but we have to give in, 10 to 20 kgs per hectare, blah, blah, fish paste. Perfect, but in sandy soils, not all your soils. And that's where I agree with Kobus. Do soil analysis. Know what is there. Measure. You cannot correct if you don't know what's wrong. Measure. Make sure. It's not like in the olden days you have to, there's a weather forecast. There's a stone. If it's wet, it's raining. If it's dry, it's not raining. We don't have to go that way. There's ways and means of getting things done and getting information. Information is power. Third thing is, please use the correct inoculant for the specific crop. I know it sounds stupid, but it's not. Lucerne inoculant is not going to work on soybeans because it's a very specific communication. It's like Jonathan that went and shook hands with, what's your name again, Stefan? And then he phoned his colleague or his speaker there at the back. It's not just something that happens. It's very specific. If I didn't want to shake his hand, then I'm not going to nodulate with him. Oh, that sounds interesting. I think it will work with dating as well. Might work with dating sites as well. Then, please use quality registered soybean inoculants. Now, this is a little pet peeve of mine. It is an L registration, and I cannot understand why. Because this is the best example of a biofertilizer that you can get. Nitrogen out of the air as ammonia to a plant to grow. But I understand why, because long ago, when we came over the Drakensberg with the ox wagons, there wasn't people that believed in microbes actually play a role in plant growth. What is it? No, we just fertilize and we just kill everything. You know, all nematodes are evil, so we have to kill all. That is the only thing that they did, was the only regulation available was the biopesticide regulations. So that's why they fell in there. But I wish we could remove it, but we need the law to be changed, and we know what the ministers are doing, not changing laws.
As soon as the law changes, it will be out.
Praise die Here. Thank you so much. Because it's really a pet peeve of mine, really. Okay, so it should actually be a M registration, a group 3, but it's not, but it's going to happen. Thank you. Hopefully in our lifetime. Maybe. Okay, let's not hold our breath. It must actually, for South African conditions, contain Rhizobium japonicum, strain WB74. Why? Because in the 1970s already, those people that did the trials, and they did it extensively. There was a question this morning for Jonathan, do you have different nodulations happening on different cultivars of soybeans? Yes, you do. Different soil types. Are there strains of Rhizobia that work better in different soil types? Yes, there is. But in the 1970s, the Agricultural Research Councils, I can't even remember their name, they changed it. Plant Protection Research Institute, dankie Wilma. They did research on many, many strains. And remember, there's no local strains those days. Soybean is not a product or a crop that is grown in South Africa. It comes from overseas. Where? Where did soybean start? That's say, lekker interactive. You see, I don't have to do all the talking. Sorry, I'm a little bit out of breath because I talk too much. Let me just quickly say that when Tom this morning said, let's close our eyes and be thankful for our ability to be here, it actually touched a chord with me. Because 3.5 weeks ago, I was in ICU in the hospital with blood clots in my lungs. And I think that is why I'm getting out of breath. But that was just like wonderful, because I'm really thankful to be here. And I know we don't have a lot of time, and there's so much that we need to do. So let's get going before the time is over. Strain WB74, you can go and look in old articles, literature and things. They did extensive. Cultivars, regions, kuduskop, the whole boxum dice everywhere. There's WB66 and 61 and 1 and 74 replaced 1 in 1989 or something like that. So there was immense and intense research done. And that's why WB74 is the best inoculant for South African conditions throughout. Remember, there can be better ones for kuduskop. But as an inoculant producer, you know how it goes in season, especially soybean season. You cannot have 5 different ones, and then these guys know we don't want to buy from you, we're going to buy from MBFI, so now you've wasted it on that. No, we're not going to buy, go to Microbia. No, we don't want those. So everybody is sitting with 5 different ones, depending on the region or the cultivar. That's just not practical. An inoculant company also wants to make money, like everybody else. So it's the best one throughout South Africa on the cultivars that was there. I think it's really necessary that we redo the thing, because I'm sure after 40 years, 45 years, there are better strains for the different varieties and cultivars that we have now. So that's something we need to look into. South African regulations, the L1 says, your liquid inoculant should have not less than 2 times 10 to the 9 CFU per mol at the end of the shelf life period. Jonathan said this morning, you prefer 1 times 10 to the 10 at formulation. So that's when you fermented it and you bottle it. That's what you want because biology will decline over time in the packaging. So if you say, I've got a 6-month shelf life, then you guarantee the 2 times 10 to the 9 or above for that time period. Then there's also peat inoculant. Very few companies do peat inoculant. I think the only one is Soygrow that still does a peat soybean inoculant. And then there's perlite inoculant. UPL does liquid as well as perlite inoculant. Now, it's very interesting. How did they get to that? And now they get confused with the regulations because now they tell you if you want a Pseudomonas that does phosphate solubilization and it's a liquid, it must also be 2 times 10 to the 9. And then you say no. And then they say yes. And then you say no, and then there's a fight, and then you get upset and you end up in hospital. This was determined specifically because they calculated that per seed you need 1 times 10 to the 5 or 100,000 Rhizobia per soybean seed for effective nodulation. And if you work that back, then you will see if it's a liquid and it says 2 times 10 to the 9, you put 100 moles per 50 kg of seed. And you saw that in Jonathan's presentation, 200 moles per 100 kg of seed. That's the same thing. Your peat inoculant used to be a 250-gram packet. So for 250 grams on 50 kgs of seed, you need 5 times 10 to the 8. And then perlite is a 200-gram packet. So it's a smaller volume. So if your volume is smaller, also on 50 kgs of seed, you need a higher count. Wow, 6.5 times 10 to the 8. So that is where that comes from. But they cannot tell us that that is what you need for your other biofertilizer products. Because it depends on strain. That is what determines the dose that you're going to use. So we've got big work to do with regulations still around living biologicals. Okay, moving on swiftly. You have to store the inoculants according to the manufacturer's instructions. Please, it's no use that they go through all the trouble and do it perfectly and then you go and you chuck it on the bonnet of your bakkie when you stop at the kantoor, kroeg, and it lies in the sun there. You understand? So then you're just messing it up. In the old days, it needed to be refrigerated. It doesn't have to be anymore. Africa is a tough country, depending on whether the manufacturer says. So just follow what the manufacturer says, and please don't freeze it. It's not like steak that's going to last longer. If you freeze it, you kill it, because little ice crystals poke holes in it, and then they leak out, and then they... Please don't freeze it. Apply it according to the manufacturer's instruction. Follow that. If he says, you know, the dosage on seed is 100 mol per 50 kgs of seed, do it. Another problem with soybean is you cannot, that's going to sound terrible now. Remember, Afrikaans is my eerste taal. You cannot wet your seed too much when it's with soybeans. You cannot actually put more than 200 milliliters of liquid on a soybean seed and not expect to have germination problems because of the saadheidjie, what do you call it in Engels? If it cracks the seed coat. If you make it too wet, it goes verrimpeld like you when you sit in the bath for too long. and then it skiers, it makes a little gaatjie and it doesn't, germinate. So use the instructions. Then dosage in furrow, according to me, I will really go for double inoculation. And when we mean double inoculation, it is one kind on the seed and then one in the planting furrow. And yes, if you do not trust your supplier, go for 2 different ones. Hey? We had that question. If you don't trust them, put one manufacturer on the seed and put the other manufacturer in the planting furrow. Then you spread your... Why do I say I would prefer double? Because we do not plant in optimal conditions anymore. Nobody does. We don't even know what optimal conditions are. Then we all have stickers. If you put it on the seed, remember what was said. They don't really come from 5 meters away to the root. So you want it the moment that seed germinates, the moment that radicule comes out, you want the rhizobia there to start the handshaking and the phone calling and the stuff like that. So you need to stick it on the seed. You cannot just, in your planter bin, gooi the poeiertjies over and then the planter runs and now you think you've got enough on your seed. It's not going to work. Plant furrow, you can do that as well. And there we want maybe osmoprotectants for on-seed as well as in the furrow. Please don't do the sticker in the planting furrow. You will block your applicator. So please get your people to understand. The sticker is to stick it on the seed. If you put the sticker in the tank mix in a plant furrow, you're going to block your little pipies and then everybody is upset and they go to a different person or different manufacturer next time, just because of a stupid thing like that. Then ensure compatibility. Ensure compatibility with other products that you're either putting on the seed or has been put on the seed or you're going to put in the tank mix in the plant furrow. Fungicides on the seed, if you put it on the seed, is it compatible? And if your manufacturing or the company that manufactures your inoculants cannot tell you whether it's compatible or not, drink a Disprin and worry about it, because they have to be able to tell you. Herbicides in the tank mix, and not even the agrochemicals people, even our fertilizer and nutritional products. Remember, there's a lot of micronutrient thingamajiggies, boron, blah, blah, fish paste, all of those things that we need. And where are they soluble? At a very low pH. Rhizobia doesn't like a low pH. So is it compatible in that tank mix? Oh, no, man, it's not poison. It's not atrazine, eh? We somewhere just chuck it in the tank and then we plant. And, oh, no, we only take half an hour to plant out this whole tank. No, you don't. Even 4 hours can be detrimental. Depending on the product and depending on the pH of that product, 1 hour in a mixing tank can be detrimental. So make sure about these things and don't just always blame the inoculant. Most of the time it's things that we do wrong. It's like with your children. You can't understand why they like hooligans. It's the way that you, lei hulle op or lei hulle nie op nie. Okay, so that's factors that promote. Factors that limit is actually just the opposite of factors that promote. But let's look at it. Nitrogen fertilizer, soil acidity, which is becoming a big problem, nutritional status of the soil towards the plant, salinity, which is really becoming a problem worldwide, especially in Africa, maybe not yet in South Africa, but we need to look out for that, temperature, drought, pesticides. Okay, nitrogen fertilizer, we're not going to go there. We already did that. It delays the whole process. No flavonoids, no handshake, no communication, no nodulation, no nothing. Acidity. Prof this morning said that a pH of 5 is where most microbes in the rhizosphere like to be. Yes,
most microbes. Remember, she's a mycologist, you know, fungi. She likes fungi. Fungi like a lower pH. Bacteria not necessarily. And Rhizobia definitely not. So optimal pH is neutral to slightly acidic, which means 7 to 5.5. That is the optimal pH for Rhizobia, the bacteria. When you go below that, it is considered acidic, and then you get problems like metal ions solubilizing and becoming toxic. Your aluminiums, your manganese, they become toxic to the bacteria, and the aluminium is actually like, you know, it's like a saber. It attaches to the Rhizobia and it pokes little holes in it, and then it leaks out once again. Gone. So that is why pH is so important. Nutritional status, like I said, for the plant, because we need a healthy plant to have optimal nitrogen fixation. Phosphorus, Kobus actually explained all of this very, very nicely. So phosphorus is a big problem if we don't have enough phosphorus. Same with calcium, sulfur, molybdenum. Let me come back to molybdenum. Tom asked about molybdenum. Way back, once again, when the ox wagons came over the mountains, the molybdenum of choice was molybdenum trioxide. That is what they used. And that is highly poisonous to Rhizobia. That's why they then moved to sodium molybdate. And you get more than one kind of sodium molybdate, okay? But it doesn't matter what kind it is toxic to Rhizobia. Long ago, once again, with the ox wagons, seed companies used to do molybdenum sprays when they produced the seed. So the molybdenum was incorporated into the seed. They don't do that anymore. And especially the brown bag, or what's the reference you said, especially if you hold back seed, there's not going to be enough molybdenum in your seed because you also didn't do 2 molybdenum sprays to get the molybdenum in the seed. So now everybody says, no man, just chuck it on the seed. Eh? But who's that everybody? Once again, it's the companies that sell the molybdenum. It's not the people that sell the Rhizobia. So we all have something to say, but we never take each other's view or each other's stance into consideration. So for me, molybdenum, I will agree, like Jonathan said, V1, V2 as early as possible. Do your molybdenum, your boron, or your, not boron, sorry, it's boron because of now, cobalt. Do it then, because then it is better. And put your Rhizobia on the seed or in the plant furrow. Don't mix this stuff together. You're going to have a problem with molybdenum, but it is essential, not only for the Rhizobia, but also for the soybean plant. Okay. And then all the other micronutrients. Now I've lost my thingy-majiggy. Salinity, like I said, in Africa, it's becoming a big problem, especially in your arid and semi-arid regions. And we know Africa is basically arid and semi-arid, unless you're somewhere close to the coast. They estimate that 80 million hectares in Africa is either saline sodic or saline sodic due to flooding, seepage, over-irrigation, all those kinds of things gives us the problem of salinity. It's harmful both to the plant as well as the bacteria, and that's why clever manufacturers include sodium chloride in their growth medium to manipulate the organism to become more, salt tolerant. I don't believe in genetically modifying organisms. I don't believe that humans can make microorganisms better than they were created, but you can manipulate them just a little bit. Because plants growing at 2, 4, 6, and 8 millisiemens per centimeter salt experienced a reduction of nodulation of between 60 and 93%. Okay, so it is going to become a problem in South Africa. It's already a problem in Africa, so it's something that we really need to look at. Then temperature, for me temperature and drought actually runs quite close together. Optimal temperature, 25 to 30. In Africa, there is Rhizobia that they isolated out of soil that could actually grow up to 40 degrees Celsius. So if you look at the correct place, you can actually find organisms that can do it, but not for those in South Africa. We even grow the Rhizobia at 28 degrees Celsius. Once again, it's not probably the optimum temperature, but you force them to become a little bit more robust. The same that you do with your other biofertilizer microbes. If it's for Africa, it has to be tough, because Africa is a tough country. So you just increase the temperature, increase whatever you want to condition them to become used to those. Once again, high temperatures, it reduces flavonoids. Why? Because the plant is under stress. And if the plant is under stress, it's not going to call a little Rhizobia, which it needs to pay 10 kilograms of sugar for 1 kilogram of nitrogen. So that's why it stops it. Same with drought. Water stress, the formation of nodules and your leg hemoglobin. Your leg hemoglobin is that thing that's pink or, in a very good case, medium rare, maroon color in your... Those things shut down. They don't want to do it anymore. And it's all about the glutamine synthesase, which cannot work anymore. So you get a build-up of nitrogenous compounds that become toxic. And remember, everything in life is auto-regulated. Even the plant auto-regulates nitrogen fixation. At some stage, it needs to decide, do I want to spend the 10 kgs of sugar on nitrogen fixation, or do I want to put it in my grain? And that's why they senesce. That's why they die off, because now we channel it into another direction. That's why I won't interfere with trying to keep nodulation going up to our harvest. Our harvest, you get the pun? And then pesticides. This was just something interesting I saw in the article that I worked from. In 2019, we had the desert locust invasion in Kenya, Ethiopia, and Somalia, and then those countries. And the FAO decided, okay, let's spray aerial pesticide, and let's almost spray it over 8 East African countries, because everybody's going to die. There's nothing to eat. So let's protect everything and everyone. And I don't think they understand what detrimental effect they had on the soil microbiome by doing this. They said, okay, yeah, it's not that bad, but what they don't understand is they impaired the microbial activities because they shifted the whole microbial composition. Some microbes were not affected, others were. So, and even when some of those pesticides are broken down, they are actually more toxic than the original compound. So pesticides, we really need to be very careful, and especially your organochloride and your organophosphate pesticides. They will also have an effect on your Rhizobia nodulation. And I think that's basically it. Second last slide. I really think it will be worthwhile. After I did this whole thing, this is actually the article that we needed to dissect. And I figured it out too late after my hospital stint. If you can, get this article. This is South Africa. This is why nodulation doesn't work in South Africa. This is why we've got problems. It was done by the ARC. Most of these people are still alive, thank heavens. It was done in 2013, 2012, 2013. It's not that long ago. 10 years is nothing. But what they concluded was, the reason why we don't have ordentlike yields, acidic nature of our soils, poor soil nutrition, especially P, and then the acidic nature, improper soil management. It's acidic, but the farmer does nothing about the fact that it's acidic. So that is a poor soil management. And then substandard soybean inoculants. Incorrect strain, not high enough CFU, doesn't survive the full 6 months or year or 2 years that it claims. This is a very, very good article. It does soil analysis. It looks at who uses a sticker, didn't use a sticker, molybdenum, not molybdenum, liming, not liming, different areas. They go all the way to CEC, percentage carbon, yield. They go all the way through, and you can actually see that there's so much that can go wrong. But if there's a few things that you focus on, you can fix the wrong. Even aluminium toxicity of 300 and 350 was negated by something else that you did right, and you got a 3.8 ton harvest. So get this article, work through it, and then you will see what can be done. But my take-home message is, anything that stresses the plant will have a negative effect on nodulation and on nitrogen fixation. Anything that stresses the plant. Thank you so much. Questions?
Okay, I'm sure there are quite a few questions for Brigitta.
I'm sure you've got 20.
Yeah, I have, but it's not for me. I'd like more input from the floor.
Dankie, skitterende lesing. Ek wil graag by jou hoor die stikstof wat 'n soja nalat in die grond, in watse vorm is dit en hoe lank kan dit nog oordra? En dan stem ek saam met jou met julle Steyn, maar ek dink dit is verkeerd om te sê dit is die enigste strain wat kan gebruik word. Ek wil julle aanmoedig om 'n bietjie nuwe navorsing te doen. Ek dink daar's uitstekende strains wat baie goed aangepas is. En ek dink ek hou nie die boodskap hier los dat WB74 die enigste goeie strain is al buite nie. Daar's goed wat al die toets deurstaan het ook.
Ek stem saam met jou. WB74, onthou, ek het nou net gepraat van WB74, daar is 'n klein huisie vol. Julle het gehoor, Jonathan noem dit af soos kinders se hoogtes of ouderdomme. Die hele klomp wat hulle het, daar is wat beter is. Maar met WB74 het hulle 'n geen ingebou wat jy hom kan neutraliseer wanneer ons 'n ander strain introduce. Want onthou kompetisie, weer eens die klomp 5-jariges wat rondhardloop, daar's reeds Rhizobiums wat daarin is, en jy kry baie Rhizobiums wat oorleef in die grond, maar dis nie noodwendig effektief nie. Hulle noduleer, maar hulle maak wit klein noduletjies. Hulle is parasiete. Hulle tap die plant vir sy 10 kg suiker en hulle gee niks terug nie. So hy moet effektief wees, hy moet competitive wees, hy moet die inherente Rhizobiums in die grond wat agtergebly het na 45 jaar se sojaboonverbouing kan. So ja, al daai goedjies, dis weer eens baie meer kompleks as wat ons dink. Die rede hoekom ek sê, kry daai artikel. Hulle het 5 verskillende enstofvervaardigers se enstowwe getoets, van poeiers na vloeibaar. Hulle het genetiese analise gedoen en gaan kyk of dit WB74 is en of dit CB wat the frikadel is en of dit Etli is en of dit Simia is en of dit, en jy kan duidelik daar gaan sien die verskil. So daar is. My vraag is net, is dit volhoubaar? Gaan ek hom kan uit die omgewing kry of gaan ons op 'n stadium sit waar ons nou maar enstof kan gooi soveel ons wil, niks gaan werk nie want die resident oudjies en inokuleer en doen niks vir jou nie. Ekskuus, ek het jou eerste vraag nou vergeet.
Die stikstof wat 'n soja nalat, in watse vorm is dit en hoe beskikbaar, watter vorm is dit beskikbaar vir die gewas daarna?
Okay, die stikstof wat 'n sojaboon nalat vir die opvolgende gewas is baie minder as wat 'n lucerne sal nalat. Jou forage crops laat baie meer stikstof na in die grond, omdat hulle nie graan maak wat ons oes, en so verwyder ons die stikstof nie. Die stikstof wat wel agterbly na soja, gaan in 'n biologiese vorm wees, 'n organiese vorm, met ander woorde, dit gaan nie uitloog nie, dit gaan nie volatilize nie, en jou mikrobepopulasie in die grond gaan dit vir jou afbreek en vir jou weer beskikbaar stel aan jou opvolgewas. Maak dit sin? Amper sê ek iets anders. Happiness. Happiness. Okay, nog?
Yes. Net om op te volg op daai vraag wat jy gesê het, hoeveel dra oor? Wat is jou, ek wil amper sê, wat is jou opinie rondom dat dat soyabone stikstof in die grond agterlaat? Dink jy dit is meer die wisselbou tussen wat 'n groter effek het en die mikrobepopulasie, of is dit actually fisies stikstof wat oordra? Ek wil net jou opinie rondom hoor, want ja, ek weet nie of daar stikstof oordra nie.
Nee, dis nie stikstof soos ons stikstof in 'n sak ken nie. Dis in 'n biologiese vorm vasgebind. So dit is die wortels wat doodgaan, die wortelknoppies wat doodgaan. Binne in daai wortelknoppies is die bacteroids of die bakterieë, selfs die rhizobiums wat nog nie genoduleer het nie, wat doodgaan. Maar al daai stikstof wat in hulle is in 'n organiese vorm en kan nie uitloog nie. Maar ja, dit hang regtig af wat jy doen en hoe jy oes en al daai tipe van goed.
Any more questions? Okay, I have one, Brigitta, and I think it could be aimed to Karen, yourself, and to Jonathan. I hear these phenomenal numbers in terms of 1 times 10 to the 10, 1 times 10 to the 9 CFUs, and that translates to how many nodules in a soya plant. I haven't seen any kind of science that shows that you need 1 times 10 to the 1 to produce 1 nodule, for example. Is there any information like that?
No, what they did at the ARC is, and that's where those 2 times 10 to the 9 for liquid comes from, is they did research and they determined that you need 100,000 rhizobia per seed to have efficient nodulation. Now, efficient nodulation, like I said, according to me, is between 5 to 7. They say 2 weeks, or at V2. I do my nodulations a week after emergence, V1. The moment you're at V1, you can take out that, spit it out, don't pull it out, you will break off the stuffies. You can take it out nicely, rinse it, and under a stereo dissecting microscope, you can actually see the primordial nodule little thingy starting. And even if it's a big nodule, you can already cut it through and it's very nice and pink on the inside. So at V1, it's already starting to bind nitrogen as long as there's no nitrogen at planting. So, and that's why I say more ain't better, because 500 nodules is going to take a lot of energy from the plant. Why do I need 500 if 25, I think it was in my slide, 25 per 2.5 centimeter taproot? That's what you need for effective nodulation. And that's why I also say, if we do the nitrogen, we can do nitrogen. But it's not full low bar, it's not regenerative, it's not what we will get better yields. But that is not actually why we're on Earth, to mess up everything and leave it like that. So I would rather go, that's why I say I check at V1, and if there's 5 to 7, then I'm happy. As long as the conditions stay good in the soil, you don't have a sudden drought or you don't have a spillage of something, then they will continue to nodulate. Does that answer your question?
Yeah, Jonathan, maybe you can comment, I don't know.
Yeah, Tom, there was some data on the 10 to the different concentrations that I put on the board at different concentrations, at different log phases. At the same dosage rates, there will be more primary nodules at in a higher concentration, so 10 to the 10 versus the 10 to the 9 versus the 10 to the 8. There will be different amounts of primary nodules formed per plant. The data actually shows it's quite level all over let's say over the 4 concentrations we tested, from 10 to the 6 all the way through to 10 to the 10. The total nodule number was almost similar, but the primary nodule number was significantly different.
Now, the only thing I missed on that slide is yield.
Yeah. Yes.
Because once again, it's like anything in agriculture. We do not sell a product because it increases chlorophyll. We do not sell a product because it increases leaf surface at V1 with 50%. We do not sell a product because it makes the roots more. We sell products because it increases yield or it improves quality. That's the only reason we sell products, not all those other little thingies that we want.
Jonathan, another quick one. So if you're using, say, example WB74 versus a North American or South American strain, does one strain produce different numbers of nodules, or is it pretty much they all produce the same numbers? I know it's a crazy question. I'm just curious.
Yeah, so Tom, there is definitely a variation between those quite significantly. Depends on also the varieties that we choose as well. The phenolics or the compounds that are on the seed influence the Rhizobium strain quite significantly as well.
So the point I'm trying to drive at, Jonathan, is technical people walk into the field on a particular variety with a particular strain and they see 8 nodules and they think that that's sufficient, but they just come from another field with a different strain, different variety, and they try and equate the two. I think they're making a mistake.
Yes.
100%, Tom.
Okay. I would like to make one comment, if I can, Brigitta, and that is you referred to Group 3 and M registrations. I can tell you that all of you are involved with this. We at Fertasa are actively working on Group 3 and the reclassification, taking Rhizobia out of L and into Group M or Group 3, if you like. But that means that we have to review, and we are reviewing, Act 36 of 1947 when it comes to fertilizers. We've got Martin here today. Martin, would you like to comment, because you're really at the forefront of this one?
Tom, I actually thought whether I should ask a question in terms of the current L number process and the requirements for the L number registration. It is significantly different from the M number, and I'm just wondering if it moves to the M number, does it reduce the new registrations in terms of the old registrations? If we look at the current guideline requirements, isn't there a requirement where the incorporation, as Brigitta said, maybe before we retire, but if it happens, shouldn't the requirements that apply in terms of the L number not be translocated for the rhizobiums in the M number?
Well, I can definitely tell you that, yes, it's actually basic the same amount of work, requirements, whether it's M registration or whether it's L registration. I would have preferred the M to be easier, like Group 1 and Group 2. You know, you don't actually have to register. You just say it's a lookalike, a me too, it's blah, blah, fish-based. But I can understand why we have to regulate it. But it's a misconception that the M registration is easier and has got less work to do, because every crop you claim on that label must be tested. And I know we stoei with the crop groups the whole time, but you cannot just do one monocotyl, one dicotyl, and now it's for everything. Yes, we know the stuff works on all plants, but you have to do the test on each and every plant. You have to do the flippin' 5-patch. Where's our regulatory woman? There she's sitting. She irritates the blue dinguses out of me because she just wants and wants and wants. But no, unfortunately, L and M is exactly the same disaster, the same amount of work, the same harassment that you get.
Tom, if I can answer, I agree it is very similar, but in terms of the L number registrations, we've just went through a set with the rhizobiums, and in relation to the normal biofertilizers, I think there is a slight discrepancy. It entails a little bit more work, and in my opinion, it is important that the transfer to the M number doesn't dilute what we currently have.
Wilma?
Ja, dis fyn. Ek wil nie 'n vraag vra nie, ek wil net eintlik 'n beroep doen. In ons professie het ons baie met klagtes te doen en hier sit 'n paar boere ook hier in die gehoor en met baie vrae en ons het nie altyd die drempelwaardes wat meetbaar is om te sê of die produk gewerk het of hy nie gewerk het nie. Maar my beroep is om die gehoor te vra dat ons 'n professionele akademisie kry om vir ons 'n boekie saam te stel rondom die produksie van sojabone in Suid-Afrika. Die meeste van ons navorsing kom van oorsee af.
Kyk, ek dink daar is 'n boekie vir die produksie van sojabone in Suid-Afrika, maar dit is meer geskoei op die bemesting en daai tipe van goed. Ek dink hulle het op daai stadium ook nie besef dat Rhizobium so mooi en groot rol kan speel nie. Maar ek moet sê SABO is in die proses om die biologiese produkte per se, nie net Rhizobiums nie, maar almal modules op te stel vir verspreiding, vir kursusse, vir om mense meer bewus te maak en te leer. So ons is besig om in daai rigting te beweeg. Wilma, jy wil iets sê?
Yeah, just two things. So maybe get to the training bit. The Protein Research Foundation has spent a lot of money on developing training sections, not training per se. I know Wessel van Wyk did quite a lot of work. There's a lot of really good videos, which will definitely add value. And there's also, if you subscribe, you can get updates on what you need to look at in various different stages of your crop throughout the year, which also can add a lot of value to the farmers directly. On the regulations going from an L to an M, there's a reason why the legume inoculants are so highly, there's so many tick boxes that you need to tick regulatory-wise. It's because your farmer are actually completely dependent on that Rhizobia for his nodulation, for his total nitrogen supply, basically, for his crop. There are things that we can't step away from and we can't limit the tick boxes. Regarding the other biofertilizers, yes, they've got an impact on your nutrient availability, but as soon as you go to the legumes, I mean, you're completely dependent on that microorganism and the product that you're going to be selling. And the farmer needs to know that that product is going to work to the best of its ability. So I'm not quite sure if you mean to limit the amount of regulatory stuff around it, but I would like to keep it at least at the same level for legume inoculants, for that risk mitigation for our growers. Thanks.
Agreed.
Great. Jonathan, you're quite tied up with the PNR, and I mean, there's a lot of information they generate on soy production. It used to be affiliated with the University of Pretoria. Maybe you guys can help me. Do they still have these info sessions, booklets, and excuse me, and such like?
Yes, yes. There's actually there's a soybean workshop coming out late in I believe in July. I think it's the 29th and the 31st of July. There's one at Nampo Park, and the other one is at the CSR, if I'm not mistaken.
Yeah, they're certainly worthwhile attending. I've been to quite a few. So in terms of information dissemination, when it comes to soybean production and all the aspects that go with it, it's really worthwhile to attend these workshops as well. Yeah. They also really do a lot of effort. Thanks, John.
They also fund quite a few audit, or let's say scientific papers per year. So if there is more from the university sides, definitely on the let's say from a biological side for soybeans and for canola as well, it's definitely something that the PRF will fund.
Yeah, great. Thanks, Jonathan. Brigitta, thank you very much. That was an excellent. Thank you so much.